Dynamics.
Hello friends. I'm glad to be here in Serbia today and make my talk to you. Today I'm going to talk true story about how we built universal CICD framework for one enterprise company. Actually, it's connected to Mike's story, so we also aimed to reduce time to market for our customer. So let's start. A few words about me. My name is Aleksander Mokanu. I'm a DevOps engineer and I have more than 10 years of experience in DevOps. In my career, I've worked for a number of customers and worked with a number of development teams and engineering teams from the companies you probably know. So let's begin. This is true story about project which we called CICD Factory. Why it was called CICD Factory? Because we were aimed to create tool which was supposed to create CICD pipelines as a mass production product, like a real factory. Project started in year 16, so about 3 years ago, and it all started with an idea. Our customer came to us and asked to create a tool to cover their demand for producing CI/CD infrastructure and CI/CD pipelines for their development teams. And they actually wanted to achieve a specific goal, to be able to create a pipeline in one day for almost any development project. Actually, I want to ask if you know what continuous integration pipeline means. You know, okay. So, why this was important for our customer? Our customer is an enterprise company with more than 10K stores, retail stores, more than 100K employees, and more than 3K engineers only in software development. And in comparison, team of this Starship was only 1,000. So we have 3 times more engineers in software development. You can imagine how many projects run in such a big company. So automation of just one specific task would save a lot of time and boost software development velocity. But we was aimed for more. On the left side of this slide, you can see how separate development teams usually spend their time engineering their CI/CD infrastructure, tools, pipelines, and so on. And every team spends their time repeating this again and again. And you probably know that not a lot of teams documenting this stuff. So every time a new engineer comes to this project, he has to spend his time to learn it from scratch or from some point. So we decided to consolidate all these activities inside one specific dedicated team, our team actually, and create this framework and share our work to reduce all these timelines for development teams. And this is especially important because today companies moving to the clouds and they moving towards microservice architecture, so number of projects grows every day. They're splitting monoliths and so on. And here comes economy of scale. Obviously, if you will have hundreds and thousands of projects, you will save huge amount of time. After negotiation with our customer, first of all, we created this organizational structure. So we split responsibilities between project teams and our team, CICD factory team. Our goal was to develop framework, to provide examples how to use this framework, to provide standard tool set across the company, and also provide documentation, updates, fixes, and so on. And obviously, we should create all this stuff based on best practices available in the industry. And the goal was to provide teams all these tools and enable them to just read documentation, write their config file, run it once, and get their CI/CD pipeline. And here comes technology aspect of all this project. So we've decided to use three basic fundamental approaches. First, and the most important one, CI/CD as a code. Using this approach, we could write all our automations as a code, commit it to repository, and then run and use it many times, as many times as we wanted. And we could, using CI/CD as a code principle, we could also apply next two principles to our automation. So inner source is approach, which is similar to open source, but as we're working for enterprise company competing on the market, they don't share their knowledge and their tools. So it's open source concept, but close to the specific company. And CI/CD for CI/CD. As we creating our project and our automation as a code, it's just basically the same code and as usual we're using to create our software. So we could apply the same techniques for CI/CD, and also this is specific. We could create a lot of tests. We could apply code review practices to CI/CD. This is usually not common. Next step, we've decomposed our pipeline to apply these principles and divided standard pipeline to small and reusable blocks and made them configurable. So our idea was to write these blocks, put them into central function library, and made them available. And after that, developers, development team, or DevOps across the company would be able to just write their configuration, enable or configure these steps, and just create their pipeline the way they want to have it, and use it, obviously, in a daily work practice. And answering to Aleksander's questions, here comes security verifications. So there was specific requirement to have security checks integrated in our pipeline. And they should be mandatory, because this is obviously practice that customer wants to have in place to be sure that nobody by the chance hard-coded passwords from production or something like that in their code. So you probably know what Jenkins is. At the moment, we had 2 plugins available to implement this whole idea, to create CICD as a code. First one is a job DSL plugin, and second one, workflow, also known as workflow plugin previously. Before we started, actually our customer created a proof of concept project. They've used job DSL plugin to create similar kind of automations, and they succeeded with this proof of concept project. And we also made our research. These 2 pieces of code, by the way, do you see the code? Are you able to see it? Okay. So these 2 blocks of code on the top part of the slide, they look similar because both of these frameworks based on Groovy language, but the conception is completely different. Job DSL plugin actually creates, by this block of code, it will create a job for the build, for the Maven build, and it will convert this code into config XML for the build job. And pipeline plugin will just execute this code as a Groovy code and just run Maven to build the code for the project. After research, we found that job DSL creates convenient jobs that all development teams used to use in their work. And it's at the moment, it was more stable and mature framework. Because pipeline had stability issues, and pipeline was had performance issues. And as our customer has a lot of projects, performance issues are not acceptable. In 1 year, let's move to the future. In 1 year, we've implemented a lot of features. I've listed not all of them, but maybe most important features we've created. First of all, number of C job conceptions in terms of job DSL. If you may not know, C job is a job that creates other jobs from the code I've shown before. We've created library containing all of these features, and we applied all these principles to our code. I will describe these features a little bit in details. So first of all, we've created this conception of this flow of C jobs. Master C job reads its own configuration and creates C jobs for the projects, for every specific project. And C job for the project checks out its own configuration and the library and creates its respective folder structure and jobs on Jenkins. And project jobs build, test, deploy, and release the code and release so this is screenshots of actual library structure we've used. It's just a common Java project structure. I've created a number of classes for our library. Here you can see some of them, and actual code, for example, of Jenkins logger. This Jenkins logger class was aimed to just serve a simple task. It covered logs inside Jenkins to make them more readable. And also, as you can see, we've created unit tests for the framework, and we've used Javadoc everywhere to automatically create documentation for our framework. This piece is about unit tests. For unit tests, we've used Spock framework. Maybe it's not close to the QA, but anyway, we've created a number of unit tests, and we've used code coverage tool named JCoco to check the coverage of unit tests. So one of the central features was configuration-driven approach. And here you can see real configuration of just one of the projects. Actually, this is configuration of our own CICD factory project. We could enable or disable some steps or provide some configurations, like here you can see GitHub section with organization, repository, and some settings. And also some specific things like, do we want to use Gradle wrapper or we don't? Next feature was role-based access control. It was one of the requirements from the customer. Here you can see configuration, and the top part of the configuration we defined roles. In the middle part called groups, we defined groups of users. And in the last part, we're just mapping for every job type we're creating. We're mapping user groups to their access rights. And this was applied to every job created just to allow only respective teams to access their jobs and see the configurations, and as well to create releases and so on. This feature was implemented a number of times for different customers, and almost every customer wants to have things like this. This is pretty basic concept. Usually you want to have inside the commit message for the feature respective number of Jira ticket. So you won't face situation after a year, for example, that you don't understand why this commit was done and what is the details of this feature and so on. So we've made an integration which actually requested from Jira if this ticket available, if it's open or in progress and not closed, not some stuff that was used before and just not workable yet. So here it is. During our project, actually in the middle of my participation in this project, we've realized that we have a number of issues. First of all, we was focused on the actual creation of the code, on the actual coding, on creation of tests and so on. And there was not a lot of projects that actually used our automation. So adoption, we lacked of adoption. And job DSL flexibility was limited by flexibility of regular freestyle Jenkins jobs. And it's not really flexible tool to deal with. And in the year 2017, Jenkins team finally started to resolving issues with the security. At some point of time, they even banned job DSL plugin from Jenkins plugins site. And they enabled script security plugin by default for all Jenkinses. And this thing actually started to break our automation. To solve these problems, we changed our approach. We started to spend half of our time. Actually, we had half of our team dedicated to work with project developers to help them adopt this automation, to talk to them, to make presentations and so on, and to solve their issues. And also we've started pipeline plugin POC. It was not done before in this deep manner. So we, at this moment, shared libraries approach for pipeline became more popular on the market, and we've decided to research this topic. Our conclusion was that actually, if we want to create really complex thing, if we want to create really complex automation with a lot of conditions, JobDSL is not able to do so, or it's really hard to implement this kind of conditions. And pipelines serve this better. One more thing, maybe you will find this useful. Configuration-driven approach is not the best approach in this situation. JobDSL itself or pipeline code itself could serve this purpose. It may be not convenient to some developers to use this code as the config, but it serves the purpose really better. So we don't create one more layer of code or config to solve our tasks. Here I just listed tool set we've used. Some of the tools was predefined by our customer, like Jenkins, Jira. At some point we've also included Docker and OpenShift deployments, trying to move our customer to the Google Cloud and to implement microservice approach. And this is our tool set we've used during this project. In concluding my speech, some statistics. During this project, maybe one of the most important thing, we've changed the way our customers see and use CICD automation. They really started to do it differently. We started with the team with the 3 DevOps engineers, and team increased to 7 engineers at the end. Not in the end, and in the middle, because project is still running. Every DevOps engineer learned Groovy language and objective-oriented programming, because it's not a common skill, to be honest, on the market to have DevOps that who can code in Java or Groovy. 4 DevOps engineers were promoted. My personal role changed from regular engineer to team lead, and to Scrum Master and Team Manager. Our engineers spent 10 months on site in business trip in the office of our customer. We've created 800 commits only in core library. There was a lot of commits in other repositories, but in the library it's this number. And we've participated in conference in the United States. We had a stand near the Splunk, Adobe, and Google. Actually, here's a photo from this conference. I want to thank you. That's all for my speech.